So here we are with another question on diode connected circuits. So these are the two circuit diagrams that we have. So in this first diagram we have this circuit. Both of them are the same. The only difference between the two is that the position or the values of these 10 kilo ohm and 5 kilo ohm resistors, they are interchanged. Okay, in for the first diagram the 5 kilo ohm is at the bottom, the 10 kilo ohm is at the top, and the second one it is interchanged. The 10 kilo ohm is at the bottom, 5 kilo ohm is at the top. The diodes D1 and D2, they are ideal. It is given. We have to find out the value of the current I flowing through diode D1 and this voltage V measured from this point A, okay, this point A and ground in both the cases. Now in any question related to diodes, the first and most important thing, the question which is very important, is to determine whether the diodes are on or off. So we take the help of assumptions. So we we use our observation skills to find out what would be the most probable condition of the operation of the diodes. So here also we'll take the help of assumptions first. Now focusing on this first circuit diagram, if you look at diode D1 and D2, see, for diode D1, P end is connected to ground, N end is connected to a negative potential. So we think we can assume that diode D1 would be on. It will be, most probably it will be on. We are not sure about it, but if we have to assume, we can make a calculated guess. Okay, so D1 I think it is on because P end is connected to 0 volt, N end is connected to a negative potential. Okay, so I think it is on. For D2, N end is connected to a negative potential minus 10 volt, P end is connected to a positive potential plus 10 volt. So I think for the first case, let's go with the assumption that D1 and D2, they are on. Okay, D1 and D2, they are on. So by on we mean that they will be behaving as short circuit because they are ideal diodes. So if we redraw the circuit, it will look something like this. This is diode D1 short circuited. Okay, then we have this 5 kilo ohm resistor, and then we have minus 10 volt. Okay, this is point B. Okay, from here again diode D2, that is also short circuited, and from here we have a 10 kilo ohm resistor, and here it is plus 10 volt. Okay, so this is the first case, plus 10 volt. This is diode D1 and D2, both are short circuited, and from here we have to find out these parameters and this current flowing through D1 I. Okay, now this current here, it has been mentioned that this current here, it is specified as ID2. Okay, current flowing through diode D2. Now if you see, let's use a different ink. if we notice here, this point B, it is directly connected to ground. Ground means 0 volt. So this point will be at 0 potential, 0 volt. VB will be 0 volt. So ID2, in between points this 10 volt and this point VB 0 volt, ID2 will be 10 minus 0 by, this is volt, by 10 kilo ohm. The resistance in between them is 10 kilo ohm. So it will be simply 1 milliampere ID2. Okay, ID2. Here it is I. Here it is ID2. Here it is I, current I flowing. Total here it is I plus ID2. Okay, so I plus ID2 is equal to VB minus 10 volt divided by 5 kilo ohm. Again, simple. VB is 0 volt. This is at minus 10 volt. And the total current flowing through this 5 kilo ohm resistor is ID2 and I. Simple KCL application, then nodal analysis in between two nodes. So here it is I plus ID2, that is I plus 1. ID2 we calculated 1 milliampere. It is 0 minus 10 volt is plus 10 volt by 5 kilo ohm, which is equal to how much? 2 milliampere. That implies I is equal to 2 minus 1, which is equal to 1 milliampere. So I is equal to 1 milliampere. Now see, current I is flowing in this direction. We assumed for diode D1, current I is flowing in this direction from P to N. Okay, we know diode conducts current in one direction from P to N. So it means our assumption is correct. Diode D1 is on. Diode D2 also here, ID2 is 1 milliampere, means the same current 1 milliampere is flowing for diode D2 also in P to N direction. Here D2, ID2, see ID2, D2 flowing through diode D2, it is 1 milliampere positive value. It means that both our assumptions that diode D1 and D2 is on, that is correct, and we have got these values. I is equal to 1 milliampere and ID2 is also equal to 1 milliampere. Next is finding out the value of V. So if you want to find out the value of V, it will simply be like this. It is connected to plus 10 volt. We have 10 kilo ohm connected and we have to find out this from this point to ground. Okay, like this. Here it is short circuited. This is how much? ID2 is equal to 1 milliampere. So if you apply KVL, it is simply 10 minus 1 milliampere into 10 kilo ohm minus V is equal to 0. That implies V is equal to simply 10 minus 10, which is equal to 0. 10 kilo ohm multiplied with 1 milliampere, it will give us 10. So it will be 10 minus 10, which is equal to 0. So V is equal to 0 for this case. So for the first case, I is equal to 1 milliampere and V is equal to 0 volt for the first case. Then we have is the second case. So here also, first let us go with the assumption D1 and D2, they are both on, let's say. Again we'll go with the same assumption, D1 and D2, let's say they are on. So we'll redraw them. It will be the same circuit like we have drawn in the previous case. Both the diodes D1 and D2 will be short circuited because we have assumed them that they are on. They would be short circuited, sorry. Then we have this resistor which is equal to 10 kilo ohm. This is collected to minus 10 volt. Then we have the other diode which is also short circuited. This is D1, this is D2. Then we have here plus 10 volt and 5 kilo. Okay, this. We have redrawn the circuit. This current here is I and this current here is ID2, and this here, this is V that we have to find out. Okay, so this is the case here. So here again we have assumed D1 and D2, they are on. On means short circuited because they are ideal diodes. So ID2 will be same thing. VB here will be 0 volt because it is directly connected to ground. D1 is short circuited, and this point here it is A. So ID2 will be simply 10 volt minus VB, which is 0, divided by the resistance involved, which is 5 kilo ohm, which is equal to 2 milliampere. ID2 is equal to 2 milliampere. Okay, now if we apply KCL here, total current flowing here is I plus ID2. So I plus ID2 means I plus 2 milliampere is equal to VB, that is 0 minus 10 divided by 10, or we can say I plus 2 is equal to 10 by 10, which is 1. That implies I is equal to 1 minus 2, which is equal to minus 1 milliampere. So negative current, I equals to minus 1 milliampere. So here there is the problem. See, here we assumed that diode D1 is on. Diode D1 is on and the current direction is like this. But here with this assumption we got the answer I equals to minus 1 milliampere. So what the problem is that the magnitude, there is no problem with that, but the direction of current is opposite. And I have already discussed in a lot of questions related to diodes and also in the basic concepts related to diodes that current can never flow from N to P side. Like this, current can never flow. It is wrong. So it means our assumption that both D1 and D2 are on, it is wrong. Okay, it is wrong. So now we have to change our assumption. So now let us go in with the assumption that D1 is off and D2 is on. Okay, D1 is off and D2 is on. So simply what we'll do is that we'll open circuit here, this thing will open circuit, and the remaining will be like that. D1 is open circuited. So it means when D1 is open circuited, directly we get one of the answers, that is I is equal to 0 ampere, because no current is flowing, it will be open circuited. I is equal to 0 ampere. Now here ID2 will be ID2 will be 10 minus 10 divided by 5 kilo ohm plus 10 kilo ohm, that is 20 volt by 15 kilo ohm. Okay, we simply applied KVL from this point to this point, because this is the only closed path available here. Because this is open circuited, no current will flow through this path. So simple, we have this closed path like this from here to here. So that is 20 volt by 15 kilo ohm. So it will be 1.33 milliampere. 1.33 milliampere. We have got ID2. So now if we want to determine V, okay, if we want to determine V, it will be, see, here it is plus 10 volt. Here we have 5 kilo ohm connected. And here we have V, okay, this point. We have to determine V. So this is how much? 1.33 milliampere. So here if we apply KVL, it will be 10 minus 5 kilo ohm into 1.33 milliampere minus V is equal to 0. That implies V is equal to, so here the value of V is simply equal to 10 minus 5 kilo ohm into 1.33 milliampere, which is equal to 3.33 volt. That is the answer. V is equal to 3.33 volt and I is equal to, here we calculated 0 ampere. I is equal to 0 ampere. So the important concept from this question that we have to take is that whenever you come across questions like this, where it is very difficult to in a straightforward manner say that this is okay, this is reverse bias or this is forward bias, like that. In that case you have to take the help of calculated assumptions. So here the diodes D1 and D2, in the first case they look most probably that both diodes D1 and D2 were forward bias, because here the P end was connected to 0 volt and N end is connected to minus 10 volt, and also D2 P end was connected to a positive potential, N end was connected to a negative potential, and our assumptions were true. Why? Because we got I equal to 1 milliampere, a positive value. Also ID2 we got around this much 1 milliampere, again a positive value. So current always flows from positive to negative, P to N of a diode, and our assumptions were true. But in the second case our assumption turned out to be wrong. Even though it looked like both of them were forward biased, the same thing, but in this case our assumption was wrong, and it can happen. Okay, that's why in the case of diodes you have to always go with the assumptions. Find out the current flowing through the diode. If it comes out positive, it means it is flowing from P to N in one direction and the diode is on. If it comes out negative, it means that the actual current direction is opposite to the assumed direction, and current can never flow from N to P end of a diode, and that means our assumption is wrong. It was wrong in this case, in the second case. So we again changed our assumption. We took that D1 was off and then D2 was on, and then we proceeded in that direction, in that way, and we calculated that I is equal to 0 ampere because it was open circuited. That was straightforward, and then we put the KVL in this direction to get the value of V. Okay, so always take the help of assumptions, make some calculated assumptions. Most of the time our assumptions turn out to be true, but in some very some of the cases the question becomes a little bit complicated. It is designed with that aspect to test your assumption skills and how quickly you can adjust if the assumptions turn out to be wrong. So in that way you can be tested, and you have to change your assumptions and make the calculations quick. Okay, so this is the solution.